Good morning and welcome to the keynote session. Today we have the pleasure of welcoming Fredrik Strömberg. Fredrik is the co-CEO of Malvad VPN and head of research at Magicon Group. Malvad was founded 17 years ago with the vision of making mass surveillance and censorship ineffective. Malvad is known for a strong commitment to privacy. It has features like RAM-only servers. It allows people to pay anonymously by not including their personal information in the payment. And it has passed a no-logs audit, does not do logging. Fredrik's main interest in the past decade has been the design and construction of more trustworthy computer systems. Fredrik and I worked out this morning that we met at PETS in 2014. From my initial conversations, I observed that Fredrik has an incredible appetite for knowledge and insatiable curiosity. And I think it's these properties that have led Fredrik to his success. So let's join in welcoming Fredrik.
Thanks. All right, exciting. I think there's some, there we go, thank you. Okay, I am super excited. Sometimes when I get excited, I sweat, so we'll see if I'm drenched by the end of this. I have attempted to compress 17 years of activity into these slides. I have 89 slides. I will not spend 30 seconds on each of them. Many of them are reference material for you to either ask me about during the Q&A or just read them afterwards if you want. Thank you for the intro. It's not how I would describe Malvad, but yeah, you will all. So there's so much to talk about. Okay, so I really like these quotes because they are excellent models. The models are necessarily simplifications of reality. They emphasize what is important and preferably hide the irrelevant stuff. And depending on the context, you may want to emphasize one thing or the other. So what I like to do is I like to look at problems from many directions. So if you have an idea and it's an amorphous cloud of ambiguity, if you apply different lenses to this cloud, then you can see it more clearly. Or for that matter, if we make an analogy to human anatomy, if we had one eye, we wouldn't have depth perception. So we and many other organisms developed two eyes, which allowed us to, you can imagine the caveman walking up the hill to get an overview of the forest and see the path that leads through the forest instead of just seeing the trees. So depth perception is very useful, as is applying many different tools to look at a problem. Okay, so let's just some meta stuff before we start. These are heuristics. They are not algorithms. That means that I will be saying a lot of stuff that you will think is fuzzy and perhaps not entirely true, or you might think like, actually, that's not how hardware works. There is such a thing as microarchitecture issues, and you're right. But models, as I mentioned, are necessarily simplifications of reality. So that's good to keep in mind. Also, this is a feeble attempt to compress 17 years of activity. I love questions, feedback, and critique. I love being less wrong or less mistaken, but wait until the Q&A. Okay. A few days ago, I figured I should start with the journey. I should give you the chronological perspective. And then I thought, actually, I should probably start with what I think is the most important stuff, and then we can run through the journey afterwards. Okay, so here's one author of a well-known design book. So I think this is a great point. The problem is not complexity. The problem is managing complexity. If you have a problem that you want to express a solution for, let's say you want to build a chip that does a SHA-256 hash or an EDDSA signature, or whatever, some graphical user experience, there is some essential complexity that has to be expressed in the solution. Now you can make it unnecessarily complicated, but that's a different matter. So the problem is not complexity. The problem is making things more complicated than they need to be. And the challenge is, how do we manage complexity, and how do we continue to manage complexity given that complexity of the systems we use will continue to increase? This is inevitable. Computers are immensely valuable. They allow us to automate all sorts of things. But if we want them to run faster, we have to have deeper instruction decoding pipelines, or we have to do esoteric cooling of the chip, such as turning off the GPU once every few microseconds because it's not needed during those few microseconds. You have to do all kinds of insane things if you want a system with a complex user experience with a good performance, or good if it's energy efficient or whatever. So how do we manage complexity? And I would say ultimately what we need to do is we need to define the right abstractions. You can say abstraction, you can say model, you can say map of the territory, which again suggests that the map is not the territory. The map is necessarily a simplification of the territory. And you need to identify, well, not need, but if you want to if you want to be more effective, if you want to increase the probability that you succeed in reaching your goal, then it's very useful to collect models and think about which models are most useful for this particular context. Okay, I don't have time to talk about all of these in detail, but here is a short list of some of the models that there's obviously more to it than just this, but these are some of the things that I use a lot in my life. So let's get right into it. I think one of the most important models is strategy as a concept. The way I think about strategy is you have the concept of goal. I am at point A, I want to get to point B. I have limited resources, which means we are in the context of economics. Economics is housekeeping with limited resources. And limited resources are usually money, time, attention, relationships, energy, health, things like that. Those are usually the limited resources that people care about. So the question is, how do I deploy my limited resources in service of getting myself from point A to point B? And the way I do that, or the way we do that, is by developing maps of the territory. We need to get an overview. We need to walk up the hill, use our two eyes, use our depth perception, look at the paths leading through the forest, see the blind alleys, see the dangers, see the opportunities, see the obstacles, see the other tools that we can find on our path when we make our way through the forest, over the lake, whatever, and reach our goal. Good maps, they emphasize what's important, they hide the rest, they are useful in many different contexts, and they remain true over time. Another really useful model that I use a lot is the concept of creativity. Creativity, in my view, is you combine two or more things that you already know about. So you know things, some of them go well together. You combine them. You can do this mechanically. I do it mechanically. I collect concepts, and then I generate all the permutations, and then I just sit there and look at, oh, I like this thing, I like this thing. They go together. Very nice. That's what creativity is, in my view. Another very important thing is when you are creative, either by yourself or when you're creative with others, is very useful to sorry, I have to breathe a little bit. Okay, so when you're creative by yourself or with others, it's very useful to initially at least to be explicit about, are we in a creative discussion or in an analytical discussion? So my dad, he is an inventor just like me, and he's invented composite materials, propeller shapes, production methods for aircraft and car industry, lots of different things. And one of the first things I remember him teaching me and my brother was, okay, so when you are creative, in the very beginning, ideas are very fragile. And if you criticize things too much, then people don't dare to, they don't have the courage, or they stop asking stupid questions. They stop coming up with stupid ideas. But young ideas are probably not the end result, but they are the seed to the end result. And so he told me and my brother that let's be explicit about, are we in a creative discussion with, we can suspend disbelief, we can talk about ambiguity, or are we in the analytical discussion where we critique and analyze? And so we did this explicitly at the dinner table, and then over time we could develop a dynamic where we would flexibly move back and forth between creative and analytical, and there was a mutual high trust relationship that we're all talking about this with in good faith, which means that people are more comfortable with talking about ideas and receiving critique because they understand that it's, yeah. Okay, so more stuff. Marginal utility, diminishing returns, very useful. Venn diagrams and knowledge, also very useful if you think about all the things you know. So if we think about creativity and then things you know, one example is me. So I've been interested in strategy, innovation, cybersecurity since I was 12 due to my upbringing and being a nerd. And then I realized, okay, I should not just practice or dabble in strategy or creativity or cybersecurity. I should practice the Venn diagram intersection of all three. So I should be strategic about my creativity. I should be strategic about my cybersecurity. I should be creative about my cybersecurity, and so on. Creative about my strategy, and then as I got more interested in building trustworthy systems, I got interested in looking at managing complexity explicitly. Okay, it's good to know yourself. This one in particular is quite interesting. There's fair amount of research suggesting that in humans, the thing that facilitates well-being and meaning the most is having positive, deep, and long-term relationships. But the nature of the relationship doesn't seem to matter very much. So it doesn't seem to matter whether it's your kids or parents or friends or colleagues. And I find this very interesting because I want to experience well-being. I want to experience meaning. And this is yet another thing that you can be strategic about. Of course, you are unique, but you also have human anatomy. You also have the brain of a Homo sapiens. And there's research about what things are we systematically wrong about, or biased, or what do we, yeah. So, okay, so here's another important model. In my experience, most complex is, so you communicate, you think you understand each other, you actually don't, you make mistaken assumptions, you have differing expectations. This leads to misalignment, leads to friction in the collaboration, and then boom, you're angry at each other, at which point you hopefully start to communicate again, and you resolve the mistaken assumptions. Then we have this one. that I don't have time to go into in detail, but basically, when I disagree with people, I want to understand what it is I'm disagreeing with them about. And this is my model of basically, for me, this explains polarization. It explains, yeah, all sorts of things related to public discourse and design and so on. Okay, here's another one. The companies that I'm involved with, I want to delegate as much as possible. I want to delegate as early as possible, as much as possible, and as confidently as possible. And this is my model for doing that. So I'm by having the right person in the right role with the right manager, by creating a shared understanding of what it is we're trying to achieve, we can develop a mutually high trust long-term relationship over time, which makes it much easier for me to delegate and for people to accept more responsibility. Very useful. Okay, then we have system design. And for those of you who paid attention to the details, you will notice that what I just described also applies to system design. Not just the group dynamics, but the idea of delegation and intent and mistaken assumptions has to do, that is related to managing complexity in technical design. Okay, so here's another model I really enjoy. So as complexity increases, we can expect intended behavior and actual behavior to diverge. And the delta between them is our mistaken assumptions, our bugs, and our attack surface. And so the very interesting question then is, with an ever-increasing number of machine instructions and logic gates and whatnot, how do we manage this ever-increasing complexity? What are the best rubber bands to keep these two lines together, the intended behavior and the actual behavior? Here's another model I like. We can think of humans as exhibiting behavior. Then we have hardware exhibiting behavior. And then because hardware is expensive to make and impractical to carry around, we amortize the cost. We need programmable hardware, right? So we don't have one chip for Word, one for Excel, one for Apache web server. We have programmable hardware that can express many behaviors. But as the first quote, the langsec.org quote said, I'm paraphrasing, wouldn't it be nice if the computers that you used only had the behaviors you wanted and not the behaviors the attacker wants? So here's another model. Instead of asking, what do we need to trust, we can ask, what am I vulnerable to, which is the same thing. And I would argue that at the limit, you need to trust the hardware, the operator who provisioned it, the software, and the developer who provided the source code. And I will explain a bit more what I mean by that. So here's another model that I use. We can think of hardware and software as going through 4 phases. The first phase is your intent in your brain. And then you formalize your intent by describing it in Blueprint, in Verilog, a hardware description language, or in source code. And then we transform it to machine-usable artifacts, and then eventually to the running system. Note that these 3 are deterministic. Once you have formalized your intent, compilers, synthesizers, place and route, PCBA, all of that is deterministic processes. So what we could do is we could look at it like this. We need to connect these two, the intent and the formalization into, we need to use formal languages and abstractions and strategies in order to do that, to make sure that what we have expressed is what we wanted. So computers do exactly what we tell them to do, but our ability to describe our intent is not perfect. And so what I'm saying here is basically we can connect the rest of these cryptographically, which I will talk about later. After being interested in security and strategy and trustworthy systems and so on, here's my short list of things that I use to evaluate new designs. So I try to use hardware defenses. because if we use hardware defenses correctly, then the attacker has to become physical, which is great. Most attackers want to be digital. If we have a suitable hardware defense, the attacker will not be able to circumvent the defense in the pure digital realm. Cryptographic defenses are also very useful, of course, because they are quantifiable in terms of how many exajoules of energy and billion years and how many Dyson spheres do we need to crack an instance of AES. So cryptography, wherever we can get it, useful. Constraining the reachable state space, that has many potential meanings. It can mean you're using a particular formal language where certain bugs are impossible to express, many other things. Distributing trust assumptions, also very useful. You can have two cores that run in lockstep that make fault injection harder. You can have multiple signatures on your software. There's lots of examples of distributing trust assumptions. And of course, we need to understand the spec, the implementation, and the supply chain. Okay. So here's, in short, I use these as tools. So the notion of category, or I didn't write this, but extension, intention, and comprehension. What are all the elements of the set? If we're talking about one thing, what are the other things of that category? And then putting hierarchy and structure into it. So using taxonomy as a way to organize your thoughts, or for that matter, etymology, super useful. Helicopter, for instance, is a compound word consisting of helico and pter, rotating wing. The Swedish word for patience is tålamod. You could see it as a compound word consisting of tåla and mod, which means tolerating courage. And I find using etymology to learn something new about the concept that I'm trying to work with it can be very useful sometimes. Oh, and then we have the design parameter space. So I like to think about designs as, what is the design parameter space? What are the things that matter for this particular design? And then I want to explore and characterize it, and preferably move it from a continuous or more amorphous realm to making it discrete. So am I able to discretely enumerate all of the dimensions that matter for this particular design? Okay, now we're on to the journey. So when Daniel and I, my co-founder, we started Mullvad, yes, we want to make mass surveillance and censorship impractical, but why? Sure, there are benefits for individuals, but for us, it's equally or perhaps more so important, what is the benefit to society? So we believe there's a net benefit to society if you can have privacy online, as I'm sure many of you will agree with me. And the reason why that is useful is because it allows this. So that is our motivation. Okay, so 2008, Swedish Parliament approved a law on mass surveillance. We started building. We saw it as we are doing direct political action through entrepreneurship. If we can start a business, if we can make it, net positive profit-wise, we can hire more people to also work on this thing that we care about. And so that was our approach. These are the use cases of VPNs commonly. We try to make geographical restriction circumvention work, but we don't care about it very much because the other ones are the important ones to us. Early on, we realized that we need to facilitate organizational trustworthiness, that VPNs and trustworthiness is tightly interconnected, as is trust, security, and privacy. So how do we do this? And we realized that we can demonstrate values and competence through behavior that remains consistent over the long term. Because if you are an individual or a group or an organization and you have goals, your behavior over time will necessarily converge on your goals, or at least you will attempt to. So it's very expensive to exhibit consistent behavior over time. It's much, much cheaper to just say stuff. Okay, we also have a long-term orientation. There's a ownership directive or owner's directive on our website you can read. There's a quote in there that says, Society grows great if old men plant trees in the shadow which they shall never sit. It's a bit corny, but it says something about our plans. We run a fairly lean and focused organization. Last time I checked, we had about, if I compare our size to the size of our larger competitors, we had roughly a magnitude, at least, less employees. And that's because one of the reasons is because we're quite focused on, like, what are we not going to do? What are we not going to spend our time on? This is just my personal experience. Many years ago, I was a perfectionist. Thankfully, I'm not as much of a perfectionist anymore. I can highly recommend that you don't try to be perfectionist. It's irrational and ineffective, and it just costs a lot in terms of time and energy. So know your biases and drives and so on. We've been consistently early or first with many things. You can read more about this later. And then I wanted to learn from the best, so I asked Roger Dingledine if I could attend a tour meeting, which he said yes to. And then I started really learning about privacy and censorship and so on. We were first with WireGuard support. We started having post-con and secure tunnels in 2017. Google Chrome was first, unfortunately. Not with VPNs, but with post-quantum security. And then 2016, I started doing more ambitious stuff. I got interested in how can we help journalists, so I tried to build a encrypting and obfuscating SD card. It didn't go very well. I had no idea what I was doing. I convinced a few engineers and business students at Chalmers and Gothenburg's School of Business. We worked on it for 2 years. It went so-so. Then I got more interested in what are the things that we can verify and others can verify about our systems. So I came up with this concept called system transparency, which I actually presented at a workshop just before PETS, which is where I met Rasmus and Tobias, who I now collaborate with extensively. Then I created an R&D team. I got more interested in hardware. I got interested in what is the most open, most minimal piece of hardware we can design that performs an ED-DSA signature. How many logic gates, what clock frequency, what languages. So we also had, so this is the ICE40 FPGA. We also had the programming and locking protocol for the in-package NVCM reverse engineered, documented. So you can now do that with open tooling. Pretty cool. And then we came up with the idea or we got inspiration from others, which is, all inventions are inspirations from others, ultimately, I think, to build a measure boot as KDF. What else? Yeah, started collaborating with Tobias, Rasmus, Filippo, various things. Organized a conference, open source firmware conference. Is fantastic. I can highly recommend it. When we had people join us in Gothenburg for OSSC 2022, I found myself on a couch with people from the Intel ME team, the AMD PSP team. There was someone there from who was part of designing the security processor in the M1. Ron Minnick, creator of Core Boot, was there. A bunch of other very interesting people. There's no security in the name of the conference, but the quality's sky high. Okay, so we created a bunch of companies. We shut down my R&D team, created companies instead. Here's the first one. One thing we designed. So I wanted to build transparent systems. But in order to do that, we need a transparency log. So we started designing a transparency log. So you can think of a transparency log as so when you have RSA or ED25519, those are digital signatures that give you authenticity. Who signed it? You can think of SIGSUM as another type of digital signature that gives you who signed it and which signatures exist for this pub key. So then you have a security model where your updating mechanism or whatever will not accept the signature unless it is globally discoverable, which is a very useful property. This is how SIGSUM works, which I don't have time to go into. In 2020, as I mentioned before, when I hired Rasmus, I told him, go read all the papers on transparency logs. He said, I've already done so. And I said, do it again. So he spent a month doing that, and we enumerated the design parameter space. And then we ended up with SIGSUM. And now we're trying to formalize it together with Elena Pagnin of Chalmers. System transparency came first, however, but I keep getting distracted and trying to build other things, such as transparency logs and hardware. The idea of system transparency is the model that I showed you earlier. What do we actually need? Like, what must we be vulnerable to? These are the 4 things. That implies if we have 4 pub keys, then we're home, right? So we can connect the different phases of software and hardware using cryptography, using reproducible builds, measured boot, verified boot, remote attestation, transparency logging, entity authentication mechanisms, and eventually you end up with what I described here. A system is transparent if there exists a globally discoverable and verifiable link between its hardware, source code, and runtime behavior. So that's the basic idea. Still not done. Another thing, Tamago, super cool idea. It allows you to run Go bare metal. Very interesting concept that I want to use for various things. I decided to fund work on bringing it to AMD 64. So now you can go from UEFI straight into Go if you want. You can run it in a Chemo micro VM. You can run it in AMD SCV SMP VMs. I'm hoping that it will be upstreamed into official Go. That remains to be seen. But yeah, super interesting concept. If you think about it, the Go language runtime is really, it kind of looks like a microkernel. It has a scheduler, it has IPC mechanism, it has memory management, it has processes. So, okay, Tilitis does hardware. The core idea of Tilitis' first product is let's use measured boot as a key derivation mechanism. Which is an interesting concept. This is pretty wild. We designed a true random number generator in a digital design. Turns out that works, because if you have ring oscillators that just feed into each other, it works pretty well. We did all the die-hard tests on 100 gigs of raw entropy and good results, so good entropy. Example use cases of the T key. Obviously, you can use it to sign stuff. You could have a verified boot on there. You could do M of N verified boot. You could do M of N verified boot and SIGSUM inclusion proof. Or you could chain things. So you could say, instead of having a YubiKey where if you press the button, you get a signature. You imagine instead having a USB security key where you can say, okay, this thing will only sign things that are already transparent. Or if you chain SIGSUM inclusion proofs, you could say, this thing, when I push the button, I know that it will only sign things if the hash is already transparent and the current time is 9 to 5, Monday to Friday, no weekends. So you can do all sorts of cool stuff if you use verified boot as a key derivation function. We tried to build an HSM. This is currently on hold because I want to do all the things, and then sometimes I start projects and I spread myself too thin, and then the designs are not good. But it's a cool idea. We have a bunch of digital designs for it. So I think this one is done. It's pretty good RNG. And then we have a crypto coprocessor core that one of my colleagues is working on. This is intended to not have like it's not large in terms of area. I'm just going to skip this. You can read it later if you're interested. Oh yeah, right. So we're also trying to do chips. So the three big challenges in open source silicon is access to tooling, process design kit, and tape outs. And unfortunately, eFabless, which is a multi-project wafer service, they ceased operations in early 2025, leading to, so this is a community that there are some academics and some private individuals who have worked very hard over a very long time to build open FPGA tooling, open tooling for open source silicon, and there are a lot of barriers to entry, to put it mildly, and a lot of this community was using eFabless to get access to the Google the Skywater 130 nanometer. That was suddenly much harder, so we sponsored work to make it possible to do on GlobalFoundries 180 MCU. Pretty cool stuff. Okay. Yeah. Backdoors and hardware is annoying. We made a test chip. It works. This is what's on it. We're going to do 2 more test chips with flash and other things. Yeah. I mean, so this is what I said before, right? There's no way I can cover all of this in 45 minutes. So I'm just trying to plant a few seeds. So those of you who are interested in hardware, those of you who are interested in transparency logs, you can look into this later or email me. Okay, then we also started Karlstad Internet Privacy Lab with Tobias, who's working on traffic analysis defense. Mullvad, the last few years, we started working with Tor to make the browser. The first time I wanted to make a browser was in 2014 or 2015. I still remember meeting Georg Koppen, David Husby, and someone else from Tor and from Mozilla. And then realizing that, no, this is far too much work and we have no money. So I had to put that on hold, unfortunately. That was in 2014. And then we deployed traffic analysis defense. And we have also gotten increasingly ambitious with our marketing-based activism. So I'm gonna show a few fun things about that. So this is what Mullvad does nowadays. One of the things: fight for freedom of speech, fight for freedom of association, fight for freedom of information, freedom of thought, and we just put these things up there to put ideas and dangerous ideas in people's heads. And then we started campaigning against chat control. Some high-profile politicians got visibly upset with us. Some of them, there's a video of one of them talking in the EU Parliament, I believe, about us. Incidentally, I mean, I have not been able to establish a link, but we have never had problems with the police. I mean, we obviously various authorities talk to us all the time and ask us things, and we say, unfortunately, we don't have any information, which is the case. But what happened roughly a month after our largest and most political marketing campaign ever was that we got a morning raid on our office. And they wouldn't tell us why, but eventually the official explanation was someone committed fraud using your service 3 years ago. This is one of the things that we had during that campaign. So this is at Arlanda Airport, north of Stockholm. So when Sweden was the chair of the EU for a period, all the politicians and journalists and so on, they would fly into Arlanda, and this is the first thing that they would see, which we thought was hilarious. We also made a TV ad. It's a play on the Dude, Where's My Car? Ashton Kutcher is one of the founders of Thorn. The video is on YouTube and our website if you're interested. And then we tried to show it in the UK and various, I don't know, agencies or something. And I'm not sure exactly. It's some like civil society, corporation, government mix. I don't really understand how. They didn't want us to show the commercial, so we did street cinema. We put up huge outdoor ads that were white with a tiny black text, making them perfect screens. In this particular case, we're just showing it on a wall. In this case, we're doing it on a building. So that's another video. It's hilarious. And then this is just like a month ago. So the London Council, they didn't like our campaign. They blacked out the government in government spyware. And then we had ads nearby. So this one is owned by the city council or something. This wall or this building is not. So we have like stop spyware on mobile devices, and then over here it's like stop government spyware. We thought that was funny. And then the day after they had blacked out the entire sign. But they don't own this part, so we could still have that up. I think they actually took the whole thing down eventually. Yeah. Okay. So that was 45 minutes. Thank you for listening. I'm excited to hear your questions, feedback, critique. Yeah.